Hello everyone, welcome to the purple classes of the Rus Indica IS Academy Desh Padla Padhai Padlo. So today we will be doing our topic on science and technology space part 2. We have already covered our space part 1 where we have discussed about the basic concept of the space, and then there we have even discussed regarding the concept of orbit. We have discussed various type of orbit: geosynchronous orbit, geostationary orbit, low earth orbit, medium earth orbit. Then we have a high end orbits are there. Okay, sun synchronous orbits are there. After that, we have even discussed regarding the various type of spacecraft and various type of rockets that we are utilizing in order to make sure that our satellite reaches to a particular position. Okay, so we have our satellite launch vehicle SLV-3, then we have a PSLV-3, then we have SSLV-3, GSLV Mk2, GSLV Mk3. Okay, then we scramjet rockets are there. We have discussed all these things in our last session, and I hope all of you have gone through that lecture and you all have understood the basic concept regarding this technology, how they are working, and I have given in proper detail in that lecture, so you can go there and all your doubts will be cleared over there. Okay, so I would be just requesting that if you are going through this session, so before going to this session, please go and read the space part 1, because from there only your foundation will be developed, and after that you will be able to build upon this. Okay, so let's start with our session right away. So this is Indian economy, GS part 3 we are doing, right? GS part 3 we are doing science and technology, space part 2. Okay, so as you all know that we are into this phase, okay, where we are discussing regarding IT, space, computer, nanotechnology, biotechnology. So biotechnology is over, we are doing right now space, and today the space part will be also over. Okay, so let's start with the first topic of today, that is Navik. Okay, you all know that we have our own navigation with Indian constellation, that is called Navik. Okay, NAVIC, Navik, as you all know that it is a word which is utilized by our fishermen. Okay, Navik we normally call to those peoples. Okay, the fishermen, which normally used to take the directions, and they provide the directions. So Navik is like a word where you get the direction from something. Okay, so Navik is a whole set of constellation of a satellite that India has launched to have our own regional navigation system. Okay, so because why we wanted our own regional navigation system is that because during the time of crisis or disasters or any type of war or anything that is happening, we become very much vulnerable. We become very much vulnerable to the technologies that has been provided by the other country. You know, we have to utilize the GPS data, global positioning data, right? GPS data, Galileo data, right? But during the war time, we may get support from the various countries or not. That depends on the relationship that we are having with those countries. So that is why, in order to remove any kind of vulnerability, okay, so we are developing our own technologies in various fields. You know, we have developed our own cryogenic engine. Okay, we have our own various we have our own Vikas engine. Okay, we have our own rocket system, right? Because we wanted to reduce the dependency. Okay, we wanted to reduce the dependency on any other country regarding any type of technologies. So it is just like that we are doing the import substitution, what we call it as, and make in India, that we are professing right now and everywhere. Okay, so this Navik system will be providing you with the regional navigation system from the Indian border up to 1500 kilometers from all the sides. Okay, So we have IRNS satellites are there, Indian Regional Navigation Satellite Systems are there. So they are providing us with two type of services. Okay, so two type of services they are providing. One type of provide is standard positioning system. Okay, so this service will be available to all everybody without any kind of restriction. Okay, and then we have a restricted service provided that will be provided only to like intelligence people, military people, police, and various other things, especially for their own use in your their working. Okay. So here you can see the main advantage of this whole Navik system is we will be discussing all the important what we call it as advantages that we are going to get with our own regional navigation system. So under the Navik, there are a lot of application that we can have with the help of a Navik satellite constellation. First of all, it will help us in boosting our national security. Obviously, whenever we are developing our own technical capabilities, we will be having our own positioning system, our own navigation system. So it can be utilized anywhere, even in the defense application, missile guidance program, border surveillance, and if we wanted to do any kind of strategic deployment. So this is whole lot of benefits that we'll be getting our when we are having our own regional navigation system. So it will help in properly finding out the precise positioning, because now we will be having a dedicated satellite system for our own functioning. We can utilize it anywhere, whether it's for troops movement, whether it's for vehicular movement, assets positioning, then global positioning, then we have a geo tagging. Okay, if we wanted to do the geo tagging, that also we can do with the help of that, right? So this is all going to work, and this will enhance our national security. Then reliability of the data. Okay, so now when the Navic function will be functioning in a proper way, so we will be having quality data with ourselves, because sometimes whenever we are utilizing GPS, it is not working as per our own requirement, right? So whenever we are creating a Navic and have our own regional positioning system, we can make sure that it works as per our own benefit. Okay, we will be getting continuous availability of positioning and navigational services. Okay, wherever you go, remotest part of our country, we will be getting any disaster that is happening, we will be having reliable and quality data. Like, you know, our country is disaster prone, like earthquake prone, cyclone prone, flood prone, right? So everywhere we can see that we if we wanted to do any kind of search or any kind of rescue operation, we will be having reliable, continuous, available data which we need as per our own standards. Okay, here I have given you an example of the Kerala floods that has happened in 2018. Okay, Navic enabled devices provided accurate location information to the rescue team, because right now whatever the data that they are using, they are for restricted uses. Okay, then we will be having accuracy. Okay, we will be having high precision positioning system, timing services. Okay, so they will be providing to the point exact data regarding transportation. They will be also telling regarding the agriculture map or land map, urban planning, whatever we are doing, we will be having our own, because we have developed for our own purpose. So we have developed in such a way that it should cater to our need first. Okay, so we will be getting proper precise navigation, like any type of like if we are trying to monitor the crop, if we are trying to monitor the wildfire, you know, in Uttarakhand right now wildfires are going on. Okay, wildfires are going on, so in order to properly monitor these, so we have designed certain instrument in such a way that we will be able to get the exact and quality information regarding that. Okay, if we wanted to have some irrigation techniques, so which area require what kind of irrigation, because in the future everything will be work on a phone based functioning or a tablet based functioning. So like if you have a large field and you wanted to open a tap, or you wanted to open irrigation. So first of all, you will be watching on your phone, and that area require some kind of irrigation. So from phone only you will be able to open your irrigation system. So until and unless you have a precise data, precise mapping of your field and everything, you will not be able to do it. So that is why this NAVIC system has been created. Obviously, then we have a disaster management during the emergency timing. This NAVIC comes into like an emergency responder, because we will be having our quality data, which is the affected region, how many people are there. So real time location, because we don't have to depend on any other navigation system. We have our own dedicated navigation system. So based on that, we will be able to properly jot down the whole plan regarding what to do, when to do, how to do. Okay, so though we have in every disaster what is happening, we will be having our own set of data. So this will help in better decision making during the disaster management. Okay, then we have a South Asian and regional corporate cooperation. Okay, so you know this is spreading around 1500 kilometers of area from here and here, from the borders of India. So we will be able to cater to the we will be providing our services to the Southeast Asian nation also, like Sri Lanka, Bangladesh is there. When it is up to Saudi Arabia, some part of the Saudi Arabia, and whole of the South Asia, including we are moving towards if Indonesia wanted to that. Okay, so during the natural disaster, we will be able to properly disseminate the information to these countries, okay, nearby countries, neighboring countries, in a better and qualitative way. Okay, now this is what is whole about the NAVIC system. So it is visible from here that we have a 7 satellite constellations that are there, that is called Indian Regional Navigation Satellite System. So we have 3 satellites that we have put in a geostationary orbit, and 4 satellites are there in a geosynchronous orbit, okay, based on the type of applicability and a functioning. So here you can see in this satellite we have a star sensor, we have a propellant tank, solar panels, and we have a liquid apogee motors there. So these satellites will be catering to our regional positioning system. So the orbital altitude is around 36,000 kilometer and cost is 1420 crore rupees. Okay, so this will be covering the area from India and up to 1500 kilometers beyond its border. Okay, so that means if you see this area, okay, so it will be covering this whole area like this, 1500 from the border of the India. Okay, so and along with that, the satellites are also having 3 extremely accurate rubidium atomic clock, because during that time we require a highly precision clocks are also required, because so that we don't even want to lose even a single second. Okay, so even after thousands of years, these clock loses only 1 second. Okay, like that is the range that they are having. Okay, so INS is having 2 way. Okay, we have a standard positioning system and restricted positioning system. Standard is open to all and restricted is open to only for the military purposes or intelligence purposes. Okay, so here that I told you that 3 satellites will be there in the geostationary orbit. Okay, 4 satellites will be in geostationary and 4 satellites in the geosynchronous orbit. Okay, so they will moving in a orbit along with the grass and traveling. Okay, so they will be accurately finding out the position. Okay, and 3 satellites in the geostationary orbit, they will be totally appear fixed from the ground in the sky. Okay, so the 4 satellite is exactly finding out the accurate position, and 3 satellites will be appearing to be fixed on. They will be looking fixed because they will be following the passage of the Earth only, and they will be helping in properly accurately finding out the accurate position of anything that is moving or anything regarding that on the surface of the Earth. Okay, so this is whole a concept of NAVIC. Now we are moving towards the NISAR satellite. Okay, NISAR satellite is a very important project, very important project where we have done a global collaboration with USA, NASA. Okay, so this is a joint endeavor between India ISRO and USA NASA. So they both will be working towards in order to have a very advanced level radar imaging satellite. Okay, so this whole project came into light in 2014, and both agencies are collaborating uh, in the functioning of this radar. So we have a L based functioning and S based positioning is there. So this NISAR satellite is synthetic aperture radar. Okay, so as the word suggests, NISAR, I just wanted to tell you that there is a full form of the NISAR. It says that NISAR stands for your NASA ISRO synthetic aperture radar. Okay, NASA ISRO synthetic aperture radar. Okay, NISAR, right? So this NISAR satellite is a joint project that I already told you. It is a dual frequency synthetic aperture radar. That means two frequency we will be using, two transponders we will be using. Okay, so this satellite will be the first radar imaging satellite that will be using the dual frequency. Okay, that will be using the dual frequency, and the main functioning of this satellite will be in remote sensing. How it is going to observe and understand the natural processes on the earth, like if we wanted to understand like how is the ice sheet, like if we say ice sheet in Antarctica, how it is behaving. Okay, so this will let us know like within certain period of time whether the ice sheet has increased or decreased. So it will provide you with exact data. Okay, right? So this whole project cost is around 1.5 billion dollar, 1.5 billion dollar. Okay, so NISAR is likely to the world most expensive earth imaging satellite that we are going to have. Okay, so as I told you, this satellite is utilizing two transponder. One is S transponder. 1 minute. Yeah, this satellite is using S based transponders, S band transponder and L band transponder. Okay, so if we go by what is the meaning of S band and L band, so S band will be a 12 centimeter wavelength transponder, that is polarimetric synthetic aperture radar, and L based will be 24 centimeter wavelength polarimetric synthetic aperture radar. Okay, so this is all about our NISAR satellite, and if you can see here, it is the main purpose of that is that we wanted to closely monitor the surface of the earth. Okay, like if it is going to detect anything, it will be providing you only a change of 4.4 inches over a vast area. That means it is going to be so accurate that there will be only a change of 0.4 inches. Like it is going to provide a deep study of ecosystem, land deformation, cryospheric sciences. Like it is going to exactly find out like where slight change in the ecosystem has happened, slightest change in the land deformation, slightest change in the Antarctica ice sheet, or whatever the other things are there. Okay, so it has a diverse field of functioning. Okay, it will monitor the various things like volcanic eruptions to disaster management, then global coverages will be there. Okay, so this is a India-US relationship, and under the US 2.2 strategic dialogue cooperation in the space situational awareness program. Okay, so here you can see this is the NISAR satellite, where this is the very big radar antenna reflector that will be first time will be put on a space. And I think in 2024, actually the launch was earlier on 2023, but it got delayed because of certain problem with the satellite system. Okay, the way we wanted to send the L band and S band, so because there is a problem with the technicalities of that, so again it has went to the NASA. So now it is planning that this will be released in 2024 this year. So here you can see this is a radar antenna reflector, which is a very big radar antenna reflector that is there. So here if you can see this antenna length, if you wanted to know the length of the antenna length is around 12 meter. 12 meter is around 39 feet. 39 feet, and it will operate both L band and S band microwave band. Okay, so this aperture mesh, what we are trying to say, this is aperture mesh, will be a reflector antenna. Okay, so here the project cost, like ISRO has bear the project cost of around $99 million, or we call it as 788 crore rupees. And we have a NASA which has provided with a funding of $808 million. Okay, so both are working on to the technicalities, and we have which I already discussed regarding the L band and S band payload, and we are expecting that we will be sending through the GSLV Mark II rockets regarding that, and that will be the orbit will be sun synchronous. Okay, dawn to dusk type. Okay, so the orbit will be sun synchronous, so that dawn to dusk it keeps on working, and this planned mission life is around 3 years. Okay, planned mission life is around 3 years. Okay, and this will be performing a final testing is going on, and after that the go ahead will be given, and the launch will be happen this year itself, maybe by July itself. Okay, so this is a NISAR satellite that we are talking about. So now we will be talking about the Gaganyaan project. Gaganyaan project is a very ambitious program of a manned space mission of India. Okay, so this manned mission was formally announced by our Prime Minister Narendra Modi on 15th of August 2018. So here they wanted to demonstrate the abilities, like how we can send a human to the low Earth orbit as close to 400 kilometers. Okay, and then we make them return back to Earth. Okay, so my main focus area of this is that we wanted to showcase India's capability of human space flight. Okay, for that India has already training the astronauts in various type of labs in our country, and how they are going to provide much more efficient way of space exploration. Okay, so there are a lot of things that are involved over here. So first of all, we should know what exactly they wanted to do. So under the Gaganyaan project, we will be sending a crew of 3 members or 4 members to an orbit of 400 kilometers for a 3-day mission. Okay, so they will be going for a 3-day mission, and then after that we will be bringing them safely onto the surface of the Earth. Okay, so we will be dropping them on the seawater. Okay, so here all the technologies and everything we wanted to make sure that we wanted to show to the people that the expertise that we are having, the experience of our of 50-60 years of launching the rockets, and also the various type of intellectual capabilities our Indian academia and research institutions are having. So these all things we will be integrating and involving in order to make our Gaganyaan mission a successful mission, because Gaganyaan mission will be also utilizing the critical technologies which we have developed indigenously. Okay, and there will be also a life support system that has to be provided for 3 days to the crew module at the same time, during the launching time and during the drop-in time. That all the things are the very critical technologies that are being there, and the crew are also being trained in Russia and India regarding their training, recovery and rehabilitation. Everywhere that research, everywhere their training is going on regarding this whole process. This is a first human space flight that India is going to have. So there are a lot of things that are there, like first of all, we have even checked with a drop test, then we have a pad abort test, then we have a test vehicle test. So that means testing at every level is going on. Okay, every level, that means is that first of all we have to check once the crew module is dropping onto the water, whether that will be successful or not. So they have already been done. Then regarding the test vehicle, LMV test vehicle that we are going to send, then pad abort test is there, then unmanned flight, after that we will be sending, and we will be checking whether the proper functioning is working on that or not. So after the integrate drop test, after the test vehicle mission, after the pad abort test, which we have already discussed over here, okay, after test vehicle, pad abort test and drop test, once everything is over, we will be sending unmanned vehicle, we will be sending unmanned flight first. And once the unmanned flight becomes successful, then at the fifth stage we will be sending the manned flight. Okay, we will be sending the manned flight. Okay, so that will be for 3 days, 400 kilometers above the surface of the earth. Okay, so here LMV rocket that we will be utilizing, LMV-3 rocket, because this is a most reliable and heavy lift rocket is there, because along the crew it has to also take the life supporting system along with them. So that is why this rocket is very, very important, because it can carry a huge load of load along with them. Okay, it has a solid state, it has a liquid state, and it has a cryogenic state. So all the stages are there. Cryogenic stage, which works at a very, very low temperature, and that also has to be reconfigured to meet the human rating requirement. Okay, so we have to make sure that whatever we are launching, and there will be an orbital module that will be orbiting the earth surface, that is at the low earth orbit of 400 kilometers, and then our HLMV-3 will be also having a crew escape model. Okay, crew escape system, which will be providing a set of quick action if anything goes out of control. We will be having a crew escape system that has to be also put in there. Okay, so here are these 4 people who got selected: Group Captain Prashant Nair, Group Captain Ajit Krishnan, Group Captain Angad Pratap, and this we have a Wing Commander Shubhanshu Shukla. These all are there who will be going on a Gaganyaan mission. So this is a very, very important mission, and this is a crew module and crew escape module. You can see over here, which is going to be landing onto the onto the Bay of wherever they wanted to provide the crew escape, or if they wanted to land any type of lander out of where, so they can utilize this. Okay, so crew module and orbital module will be there. So crew module will be a very, very important habitable space, so with space earth-like environment. Okay, it is a double walled construction consisting of pressurized metallic inner structure, okay, and unpressurized external structure with thermal protection system. Okay, so there will be crew interfaces, human-centric products will be there, life supporting system will be there, avionics will be there, everything will be there under the crew module. Okay, so they will be all helping in properly helping the crews to remain there for 3 days. Now we are moving towards the next important project, that is Project Netra. So what is the meaning of Netra? Netra in the Hindi we call it as eyes. Okay, that means Project Netra is going to look something into the space. Okay, now we are talking about space junk. You know, lot of satellites, lot of rockets, even asteroids, meteoroids, and various type of rocks or anything are traveling at a very, very high speed in the space, right? So government wanted to track all these things. Okay, so space junks are there, rock stages are there, dead satellites are there, debris of anti-satellite system, debris from anti-satellite checking systems are there. Okay, and they are traveling at around 27,000 kilometer per hour, that is having a very, very high velocity at the low earth orbit. Okay, even if a small segment of 10 centimeter is also traveling at that speed, it poses a huge threat to the working satellites into the orbit right now. Okay, because it poses a threat to the operational satellite. You might have heard of the Castle syndrome. Okay, Castle syndrome says that there can be a chain reaction that may occur if there is a collision between, and it may create more debris, that these debris will collide with some other satellites, and other satellite debris will collide with other debris. So it has a potential, it will render the whole Earth's orbit unusable, because if millions of debris are rotating in the low Earth orbit, it is very difficult to put anything onto the orbit at that place. Okay, so this is regarding the project Netra. So with the space junk possessing a increased threat to Indians' asset in the space, so Indian Space Research Organization is building its orbital debris tracking capability, like how we can track the orbital debris. Okay, so in this pursuit, what we are doing is that we are making a radar with a range of 1500 kilometer and an optical telescope which will be inducted as a part of effective surveillance and tracking system. Okay, that is Netra. Netra means Network for Space Objects Tracking Analysis. Okay, what is that? Network for Space Object Tracking and Analysis. Okay, Netra project. Okay, we all know regarding these space junks and everything, and Kessel syndrome just now we have discussed. Okay, so there are so much of space junks are there which may create a cascading effect regarding that. Okay, so project Netra will be doing what? Okay, this project Netra will be doing what? So here we can see it will establish a early warning system in space of detecting various hazards. Okay, so this will work like a early warning system, like if anything is, any debris is coming, so it will this radar will be able to track, and this radar will be able to properly inform that something is on their trajectory. Okay, like debris or of any Indian satellite or foreign satellite maybe in that case. So this will help in emphasizing, like we so that our space situational awareness, so we have to create regarding the safety and sustainability of our space asset. So we need to have a proper tracking system. So under the project Netra, we have a various components are there. Okay, so they will be having connected radars, so we will be having telescopes, we have a data processing center, we have a control centers. Okay, so what is the connected radar that will be doing? So that is why this project Netra has been put in order to provide the early warning system regarding the space or any threat that Indian satellite are having because of the space junks. Okay, so as I told you regarding the connected radars are there. Okay, they will be detecting and tracking the objects that are revolving around or nearby the satellites or anything like any space debris or any space object, and they will be providing proper data, and they will be analyzing, and they will be predicting like what it is going, whether it is going to hit the satellite or whether it is not going to hit, or whether it is off tracking. Then we will be having a telescope, okay, with advanced optic system. This will further enhance the capability of further observing in the space with more precision. We will be having more and more precision, so accurate tracking will be happening. Along with the connected radars, we will have a telescope system, and once the data of connected radar and telescope will be feed into the data processing units, where all the data will be collected, and proper flow and proper algorithm and computational techniques will be utilized in order to exactly find out the path of that, to find out the trajectory, in which trajectory any object or any type of space junk is traveling, what is the velocity, direction, and whether it is posing any kind of threat to Indian satellite or not. Okay, so this control, there will be a control center of the project Netra, which will be controlling and coordinating and operating the observational satellite, and this will be keep on providing us with real time monitoring of space activities wherever it is going on. Okay, so capability, like it can detect up to as small as 10 centimeter in size of any object. Smallest to smallest object can be detected up to a range of 3400 kilometer. That means from low earth orbit to a middle earth orbit, right? So any satellite which is up to a range of 3400 kilometers, and if there is any kind of space junk that is traveling, it is able to capable of tracking, right? So what exactly is the significance, we have already discussed. And with this project, with this functioning, we will be having our own SSA capability, that is space situational awareness capabilities we will be having. And India will be again joining only a few faring nations which are equipped with their own advanced system of monitoring of the space activity. Okay, so this SSA will be detecting the threats, will be like anything, whether it can be a collision with a debris or any flyby pass. Okay, so this will be telling, and this India will be having our own space situational awareness program. Okay, it will be helpful in geostationary orbit monitoring, because if we are aiming to extend our surveillance capabilities, that is around 36,000, geostationary orbit is around 36,000 kilometers above the surface of the earth, because at this surface, at this place, our all the communication satellites are being put normally. Okay, so we have to further enhance our capabilities to monitor at this level, because if any of the space debris or junk is hitting our communication satellite, it may be very, very disastrous for our own country, because it may hurt the whole communication in our own country. Okay, so there is a need to further extend the capabilities of this project Netra, so that we can able to track up to 36,000 kilometers, up to 36,000 kilometers, where normally all our satellites at a geostationary orbits are being kept. Okay, so here we are also taking help of the international participants, and efforts are being there, and we will be also providing, like since we are focusing on our Indian satellites, so but we will be getting the data from all the places, so we can even provide some warning signals to our collaborators or various other organizations, so we can work on a data sharing mode. Okay, we can share our data, they can share their data with us. Okay, so we can work on a collective way. Okay, so this will be this will be providing us with early warning system that we have already said. That is the first advantages of that. We will be having our own space situational awareness capability. Okay, so this will also address the challenges of increasing satellite launches, because we have every day, someday or other day, we are satellite launching are happening from the earth's surface. So in order to avoid collision, so if we have a data coming from various places, so we will be exactly find out, we will be able to precisely find out what is the trajectory our rocket has to take in order to avoid any kind of collision. Okay, so we have our all observation facility like radar, telescope, data processing unit. Okay, ability to spot up to close to 10 centimeter up to a range of 3400. So we are expecting that we should increase it to 36,000 kilometer, where our all geostationary satellites are being placed. That means our communication satellites are being placed. Okay, so this will further and then we are also collaborating internationally, and this will also prevent it will enhance our national security at a large. Like if we have any type of attack that is coming from air, space and sea, it work like a radar only. Okay, so right now what India is using, this is a new technique, but right now India is using multi-object tracking radar, which is kept at Sriharikota, but it has a very limited range. Okay, and we are also dependent on the data from NORAD, okay, and other public sources, because and they are also not being providing us with proper accurate data or any kind of data. Okay, so we have to so ISRO has to coordinate with SSA Control Center in Bangalore and Space Situational Awareness Management in order to get the data. Okay, so project, and there are other global initiatives like Clear Space One is there, which is aiming to eliminate the debris from the orbit. Okay, so there are certain projects that are going on which is trying to remove the debris also. Okay, tracking the debris and also removing the debris from the track. Okay, so these are projects are going on which are tracking also, and some projects are going on which are trying to eliminate the debris from the. Okay, so right now we are utilizing multi-object tracking radar, which have a very limited capability, but with Project Netra we will be having a much more enhanced capabilities. Okay, now we are moving towards a project Bhuvan. Now we move on to the next topic, that is Project Bhuvan. Bhuvan is, as the word suggests, Bhu means land. Okay, Bhu means land. Okay, so there is something related to the land mapping and everything. So this project is very important. If we consider, if we go and we find that we have a huge 32 lakh square kilometer of the area, that means 3.2 million square kilometer of the Indian mainland is there. So we have a rural areas, we have a urban areas, we have a transitional areas. All are these areas that are there in our country. Okay, so Bhuvan is a Bhuvan Panchayat version. Bhuvan project is a type of a project, and this is a web portal. Okay, Bhuvan is a web portal which is taking data from the satellite. Okay, where we can plan it, and which is also helpful in monitoring various type of government project with the help of a web portal. Okay, so the main purpose of this Bhuvan Panchayat is Bhuvan project is to facilitate better planning and monitoring of various government projects that are going on. So here where the satellite come, here satellite imagery and advanced data analytics are being utilized. Okay, satellite imagery and advanced data analytics tools are being utilized in order to properly analyze the area, properly find out the area, and how we can properly manage that area. Okay, so whenever we talk Bhuvan is directly connected to the rural areas of our country, where a lot of government projects, even the urban areas are there, where that is all connected. Okay, so this is a web portal which has been created, which is having a feed on data from the satellite regarding the land, type of a land use, what type of settlement is there, what type of infrastructure is over there. So for the public, you can get access to information regarding type of land use that is happening, type of settlement that we are having, type of infrastructure that has been created over there. Okay, respective panchayats. Then it is helpful for Panchayati Raj institutions also, where the members of Gram Panchayat or Gram Pradhan, or at a district level or a Samiti level, you can utilize this whole portal, and based on the data that is there in this portal, which is feed on from the satellite, for better informed decision making, and how you can allocate the resources at various places with the help of this data. Okay, and everybody is involved in this whole process, whether government, local government, people, then various type of offices and everywhere, where they can visualize the data. Okay, you can go to the Bhuvan portal and you can see and you can visualize the data from the satellite itself, and then you can try to map out the data, find out where the vegetation is there, where the plain land is there, where the agriculture land is there, and then based on that, based on the analytical information, you can find out the whole process. Okay, so here in the Bhuvan version, we are having a very important features are there, like high resolution database is getting created regarding like the type of a land, the variety of land uses patterns are there. Okay, so they are utilizing Bhuvan satellite imagery. Okay, imagery, right? So they are getting high resolution images, right, about the land use, about the land cover, about the settlement, where is the road is going on, where's the rail network is there. You are getting the exact high resolution images from the top. Okay, and it is feed onto this portal, right? And based on that, you can visualize the spatial data, interactive maps will be there, graphical representation, whatever you want. If you want interactive maps, that you can also get. You want graphical data, that also you can get, based on the type of usability this portal is going to provide. Then after getting the data, after downloading the data, you can properly utilize the various type of analytical tools. Okay, you can utilize various analytical tools to analyze the spatial data, identify the pattern, like if we have this here and we have this forest cover was there earlier. Okay, then after some times this part is removed. Okay, so this is a pattern. Okay, this is a pattern that you can find out, and based on the pattern then you can take informed decisions. Okay, then this portal will be able to generate automatic reports also. There certain parameters are there that you have to feed on, like you want it from which date to which date, under what data, whether you want maps or whether you want graphical representation. Once you have put in all the data and you put a button, and you will automatically, the report will be generated for you. Okay, so and then it will also be helping you by providing model based product services. Okay, and this whole process will be implemented in collaboration with ISRO, Gram Panchayat and other stakeholders, those who are being part of this whole process. Okay, so here you can see this is a Bhuvan portal, gateway to Indian Earth observation data product services. Okay, so it is an initiative of ISRO. Okay, they will be showing Earth observation capabilities. Okay, they will be exploring the virtual 2D Earth and a 3D Earth from the space itself. Okay, so it will be helpful in vegetation, then finding out the water bodies and the patterns in the water bodies and the quality of water bodies, then mountains, then type of mountain, the slope of a mountain, and then various type of vegetation. All this you can track from here, and based on that, informed decision can be taken. Informed decision can be taken from that. Okay, if you wanted to find, you can go to www.bhuvan.nrsc.gov.in and you will be able to find important information there. Now we are coming into the very flagship interplanetary mission that government has launched in 2013. Okay, in 2013 government has launched an interplanetary mission that is called Mars Orbiter Mission, or we call it as MOM. Okay, and in Hindi we call it as Mangalyaan. Mangal, as you all know that Mars we call it as Mangal Grah, right? So that is why the name as the Mangalyaan. Okay, so this was launched on November 5th 2013. Okay, so this is launched by Indian Space Research Organization in order to explore the surface of the Mars, atmosphere of the Mars and mineral composition of the Mars. Okay, with this entry, with the success of this mission, India has moved into a global club, exclusive global club entry, where only few elite countries are there, like Russia, Japan, France and European Union. Okay, so our Mangalyaan Mars Orbiter mission has been sent in order to show India's space technologies and show to the world the ability of India to take complex mission. Okay, and one of the most striking feature of this mission is the cost effectiveness of this whole mission. Okay, so Mars Orbiter mission is a highly cost effective mission which has been sent at rupees 450 crore only, that is close to $73 million. And on that year only, the NASA has sent their own mission that is called Maven mission, which is costing $670 million. Okay, yeah, we know that they may have their different type of payloads with them, but yeah, during the first time, India has a first maiden mission and first maiden and successful missions that has been created by our country, that is Mars Orbiter mission, which has been sent. And people say that we have sent the spacecraft to the Mars even at a cost less than of auto price that is earlier during that rupees 7 per kilometer. Like that means it is much below the price of a auto which is there in our country for traveling 1 kilometer. Okay, so whenever we send any kind of mission, obviously there are certain objectives associated with it. Okay, so what are the main objectives that we have sent? First of all, the main objective was to study the surface. What is the surface composition? Okay, then what is the atmosphere, whether thick atmosphere, thin atmosphere, type of gases over there, okay, pressure situation over there, right? Then we have a mineral composition, like soil is made up of what? Soil at the Mars, soil is made up of what? Okay, so all these things are being sent. So along with them, a lot of payloads are being sent, okay, in order to understand. But since this time we have only sent the orbiter, Mars orbiter mission, so we were having only orbiter. That means there is an orbiter, this is the mission, and this is orbiter. Okay, so this will be only orbiting the Mars outer surface, it is not landing on the Mars surface. Okay, so this will be observing all the things from the distance itself, okay, whether atmosphere, whether mineral composition, or whether type of what type of surface. So we wanted to exactly find out the Martian environment, Martian atmospheric composition. Is there any presence of methane? Because methane presence shows certain life form was over there, okay, and various type of surface features, heights and lows and everything. Okay, so this data can be utilized by our scientists, and based on that they will find out the geological history of the Mars, or if there are any kind of life forms there is, if we have any type of habitability over there, like in future if we want to go to Mars and live in Mars, do we have any kind of habitability over there, and what is the atmosphere dynamics over there. Okay, so with the success of this mission, we have shows that world that we have ability to design, develop and deploy even a interplanetary mission for scientific exploration. So Mars orbiter mission got successful insertion into the Mars orbit on September 24, 2014. Okay, this shows ISRO and put ISRO's onto the limelight during that time, like how the way they have defined their orbital maneuver, critical aspects of the interplanetary missions. Okay, so with this Mars orbiter mission, and ISRO has shown a lot of technological know and how. So because of that, ISRO are now getting ISRO is now getting offers to have an international collaboration in further interplanetary mission with various space agencies outside the world. So here you can see this is the whole process that we have used. So here we have a Mangalyaan, has a launch weight of 1350 kilogram. Project cost is during that time 73 million. Okay, so it just whatever we have said is fine, and it has been sent with the help of a PSLV, polar satellite launch vehicle. So we all know that we cannot simply send directly this polar satellite launch vehicle and put it onto a trajectory, right? So polar satellite launch vehicle has helped in reaching to the orbit. Okay, here I wanted to show you. So the polar satellite launch vehicle has put this satellite into the orbit of the Earth. Okay, like this. Slowly, after every maneuveration, we try to increase the orbit of this Mars orbiter mission. Okay, after every certain time, we are increasing the orbit of this Mars orbiter mission, right? So after certain time, when the time has come, we have given a final firing, and it has been sent towards the Mars. Okay, so this whole process was done in order to reduce the cost of launch. Okay, so we have taken the scientific measure in order to reach towards the surface, towards the orbit of the Mars. Okay, so this is how, with further increase in the orbit, and after the final stage has come where we require very less time of fuel, and we have final firing we have done, and it has moved towards the Mars, and it took around 9 to 10 months in order to reach there, and it has inserted into the Mars orbit. Okay, so we have started with the first stage. Okay, first stage is what? I'll just tell you here. In the first stage, the satellite circles the Earth several times, each time going further away from the Earth, right? Then we have a second stage, the satellite is put onto a trajectory to the Mars. Okay, then the second stage, this is why here we have done a final firing, and we have released the satellite to go towards the final trajectory of the Mars. And at the third stage, we have done the satellite begins to orbit the Mars like this. Okay, so along that Mars orbiter mission, we have sent various type of payloads. Okay, we have a Menek payload, TTC antenna is there, high Galen antenna is there, then medium gain antenna is there. So this is all taking the images of the Mars to understand the composition of the Mars and everything. So this is all the whole technical know-how regarding how the Mars insertion mission has happened. Okay, Now we are moving towards the next topic, that is called Mission Shakti. Mission Shakti means it is related to the Indian anti-satellite weapon system. Okay, anti-satellite AST system. So under the Mission Shakti, we wanted to increase the India's defense and space capabilities. So with the help of two big organization and most important organization, that is DRD, Defense Research and Development Organization, and Indian Space Research Organization, we have recently tested a anti-satellite weapon. Okay, right now we are expecting that the warfare may reach the space in the coming years. The countries may start targeting the important satellites of the countries. Okay, so here in the Mission Shakti, India has shown their indigenous anti-satellite technology. Okay, so India has targeted and destroyed its decommissioned Indian satellite in the space, which shows that India now has a capability to target the satellite in the space. Okay, so this whole test was conducted from the Odisha Balasore district. Okay, because at that place we have a very good conducting. At that place only various type of testing happens for safety and precision. Okay, so here with this Mission Shakti, India has got entry into an again elite group which have a capability to target the satellite in the space. So now India is a country which is having a weapon to target the satellite. So that is India anti-satellite system got successful with this use. Okay, so what it is going to provide us, like if we have a satellite testing, so what it is going to provide us. Okay, satellite weapon test. So the one of the most important significance is the strategic significance. Now with this launch, now India has the ability to protect its space asset. Now you will see how India is going to protect our space asset with an anti-satellite weapon. The main thing is that it have a deterrence. Like nobody can threat India with its space attack. Okay, because India also have a capability. If if somebody is threatening India, so then India can also threaten over them with that. So it provides with a deterrence. Okay, so this will help India to have their own safe communication, navigation and satellite. Because like if you have a nuclear weapon, and if anybody other has a nuclear weapon, so there is a more likely chance that they do not go for a nuclear war. Okay, same type of a power deter the people to work on anything. Okay, so with this anti-satellite weapon system, we also able to show India's technological advancement. Okay, in space and defense, that means India now has a full capability of attacking anything into the space with a test of the anti-satellite weapon system. So that means India has a capacity to innovate, India has a capacity to develop, India has a full control over the cutting edge technology, and now India is developing this all indigenously. Okay, so with this system, India has entered into again a global elite club. Okay, so India has moved into the global elite club. Okay, so now India become a more and more responsible country, and India has got a global recognition throughout the world, which shows that India is technologically advanced and moving, and India is showing a responsible spacefaring nation. Okay, then we have a indigenous endeavor. Okay, we have a Mission Shakti, which shows that we have our own indigenous capabilities that we are developing regarding space technology, whether it is satellite, whether it's communication, whether it's rocket, whether it's anti-satellite weapon or anything. We are having our own set of indigenous development, whether it is scientist, engineer, researcher or whatever. So that means India has a full capability for developing complex and sophisticated defense system. Okay, and now India is showing a limited deployment of all these areas, that India is not focusing on any kind of warfare in the future, or India is not in any kind of arm race. India has developed only that much very limited deployment which will deter other nation. okay, to follow the responsible behavior. Okay, so India has created only that much which will deter the other countries and force the other countries to follow the responsible behavior in the space field, okay, for the peaceful purposes. So this is a mission Shakti, India's anti-satellite weapon system. So it is a power mission that we call it as 300 kilometers in 3 minutes. Okay, so India DRDO has conducted it. Objective is to safeguard India's space assets. This is an Indian satellite that we have target. Okay, that is a decommissioned satellite that we have target. Okay, so missile is ballistic missile we have utilized as a defense interceptor part. Okay, so we have utilized a defense ballistic missile, and technology is India's called kinetic kill, which is a flyby test and jamming. Okay, yes, does the test create a space debris? Obviously, whenever there is a hit that is happening, obviously it will create a space debris. Okay, because since the thing is that we have done at a lower earth orbit, so any debris that is generated, this will fall back onto the earth's surface, and whenever they are falling back to earth's surface, they get burnt away and they just fall back within the week's time, and these debris are very, very small, which can create any kind of harm to the people. Okay, but yes, still sometimes sometimes the debris can be of larger length also. So here you can see we have launched a satellite, we have to launch a missile from here, ASAT satellite missile, and it has targeted the missile in 3 minutes, 300 kilometers in 3 minutes. That means for 1 minute 100 kilometers it has traveled and hit the satellite, and now India has joined a club 60 years later regarding that. Okay, so during like if we go onto the historical part of it, like during the Cold War time, USA and USSR all are working on anti-satellite weapons during that time, and they all have tested around 1959, and in 2007 China has utilized this first ballistic missile to destroy its own weather satellite around 861 kilometers. So India has utilized this at a lower earth orbit. Okay, so here it is a satellite. Here you can see the satellite launched and it has hit back and test. Now Chandrayaan. Now Chandrayaan, whenever we it is related to the Shukra Graha. Okay, in Hindi we call it a Shukra Graha, and it is called Venus. Okay, this is also called as Earth twin. Okay, so Indian Space Research Organization have started the concept regarding in 2012. Okay, but right now the project is still at a nascent stage, and government is focusing on to further boost this. So Indian Space Research Organization is asking and inviting payloads. Payloads means if we are sending some kind of rocket and rocketry or any satellite to that place, what payload or what kind of research instrument that satellite is going to carry. Okay, so so ISRO is asking for various private institution for proposal regarding, and various research institution, like what type of payload we can send along with that. Okay, it is a Sanskrit word with the Shukra, it's a Venus, right? And Yana, Chandrayaan means your craft or a rocket that we wanted to send. The main purpose is that we wanted to send an orbiter which will be looking regarding the type of atmosphere of Venus surface. It will be mapping atmosphere and geological composition, right? And India is also looking forward, like we will be finding out the type of a microbial life that is present over there, and if there is any potential existence of microbial life. Okay, for like if there is any kind of microbial life, so this will further boost the research in that whole areas. Okay, so even NASA has even said that it is very, very unlikely that we will be finding any kind of life over there. Okay, but still ISRO is yet to focus on finding out some kind of microbial life. So the previous missions are European Space Mission, that is called Venus Express. Okay, and then we have a Aksui Venus Climate Orbiter is there, which has been sent by the Japanese and which have entered the orbit in 2016. Okay, even NASA has sent their Parker Solar Probe, like they are sending it to the solar toward the sun, but they have done a pass by from flyby from the Venus, okay, just to capture a visible light of the vision surface in 2021 in order to find out. So India is focusing dedicated mission of Chandrayaan. With the help of this whole process, we will be able to exactly find out and map the atmosphere geological composition and also find out the microbial life in the Venus. Now we are coming into the ExpoSat. ExpoSat stands for India's X-ray polarimeter satellite. Okay, X-ray polarimeter satellite. Okay, so this was developed by our own institution like Raman Research Institution and UR Rao Satellite Center in Bangalore. So this concept, the whole concept of this satellite was conceived in 2008, and the main focus of this satellite is to check how the cosmic X-ray polarizes. Okay, polarization of cosmic X-rays, right? So very important mission, especially focusing on a type of a spectrum which is called cosmic X-rays, because these X-rays are being emitted by celestial bodies, maybe black hole, neutron star, pulsar nebula, which is outside our solar system. Okay, so this will be helpful in studying how our universe came into being, how many years, because right now we know it is because of the Big Bang. So so we are trying to study this cosmic X-rays with the help of EXPO satellite. Okay, X-rays polarimeter satellite. So this satellite is containing two payloads, that is Pollux and Expect. Okay, Pollux is developed by the Raman Research Institution. Okay, that will be observing 8 to 30 kilo electron volt energy band, and Expect satellite, Expect X-ray spectrometry is the fast timing and good spectrometric resolution they are having. Okay, so they will be complementing, this will be complementing this Pollux observation. Okay, and this will be providing you with a long-term monitoring of the spectral state, and this will helpful in understanding our formation of various celestial bodies like black holes, neutron star, and various other things. Okay, so this will help us understanding complete astronomical emissions that are coming, because we know a lot of rays are coming, X-rays, gamma rays, alpha, beta rays, all these rays are coming. So we will be having a complete set of astronomical emissions that are coming from black hole to neutron star. So this will this whole the aim of this EXPO satellite is to conduct a polarimetry measurement of 50 potential cosmic sources. So we have already identified sources from where we have to measure this. Okay, then we will be also measuring long-term spectroscopic study of the cosmic X-rays, and we will be also combining polarimetry and spectroscopic measurement in the common energy band. So these are some of the technical things. We are not going too deeper into that. We just know what is the meaning of that satellite and why it has been launched. Okay, so this is a satellite will be measuring the polarization. So we have a Pollux detector over here we are having. Okay, and if you wanted to see, you can see the view payloads from here, and this mission life is 5 years, and payload will be Pollux from the Raman Research, and it will be orbiting in the low Earth orbit of 500 to 700 kilometer from the surface of the Earth. Okay, now we have a geoimaging satellite that we call it as GISAT-1, geoimaging. Okay, so the main purpose of this satellite is to monitor the Indian subcontinent from a geostationary orbit. Geostationary orbit is 36,000 kilometer above. Okay, this is especially focusing on monitoring, right? So this helpful in monitoring our like if we have any kind of disaster that is happening, like flood is coming, then we have cyclones are coming, landslides are happening, and if we wanted to measure the agriculture area, type of agriculture area, forest to type of forest, then urban planning and other things. So it will be measuring from the very top, so it will be providing much more coverage from the single place. Okay, so it will be monitoring like floods, cyclones, forest fire, landslides. It will be providing real-time imagery data. Okay, so because of this satellite, geoimaging satellite, authorities will be able to swiftly respond to emergencies and mitigate any kind of impact. Okay, so that is why we will be keeping that into a geostationary orbit, that is 36,000 kilometer above, and it will be orbiting a fixed position. Okay, so this will be providing a continuous coverage of that particular region. Okay, so this will be fixed at particular location, and it will be sending the data from that particular fixed location, right? So it will be a very high resolution sensors and high resolution imaginary services will be there. So their sensors will be able to detect the type of land use, the type of vegetation, health care, the type of vegetation health, whether the vegetation is good, bad, or in different shape or something like that, types of water bodies underground, upper water bodies, and atmospheric conditions that are all being part of it. So it will be imaging at a very long distance, so it will be able to image everything and very precisely. Okay, so a big sense, this will be like looking like a fixed at a certain position, so it will be continuously monitoring at that particular location. Okay, like if you try to put something at a very long distance and you are monitoring this area, so it will be monitoring this whole area. So from 36,000 kilometer you are keeping the eye on your India, so it will be observing each and everything over there. So continuous monitoring will be happening of Indian subcontinent. Okay, because some satellites are there which are in the low earth orbit. Okay, which are in the low earth orbit. So since because of their height very low, like from 400 to 1000 kilometers, so they are not able to properly map the whole earth, so they have a limited coverage. But with the geostationary satellite, they are being kept at a very long distance, so they will be able to properly map a large number of areas. So this application will be in disaster management, agriculture, forestry, urban planning, and weather forecasting. We are naming just few of them. This is a geoimaging satellite that we are having. So here you can see we have already sent this with ISRO GSLV MK2 on January 14, 2020. Okay, so GSLV MK2 we have taken, and the main thing is that it is an Earth observation satellite into the geostationary orbit, that is 36,000 kilometer of the Earth, and it has a mass of 2100 kg. Okay, destination is geostationary transfer orbit. Okay, and the payload means what it is carrying, what satellite it is carrying. It is geoimaging satellite 1. Okay, so I hope all of you have got the criteria, like why this geoimaging satellite has been set. Is just like that, we wanted to map the whole area. So until and unless we keep something something at a very long distance, like if I wanted to map a certain tab. Okay, like if I wanted to map this, okay, I am keeping a satellite at a very close by, so it will be only mapping certain part. But if I am keeping a satellite at a very long distance, so it will be mapping this whole area. Okay, it will be mapping the whole area like that. Okay, so this is how you can imagine like how we are going to work on it, right? Now we are moving towards the next type of satellite, that is called Reset to BR1. Okay, Reset to BR1. It is again advanced level of just 1 minute. This is again a advanced type of radar imaging satellite. Okay, radar imaging. So it will be again imaging the Earth from the space. So this satellite will be having a synthetic aperture radar. Okay, this will be having a radar, that means a antenna and radar will be kept over there. So the main purpose of that is radar imaging. Okay, so it will be finding out the high resolution images of the Earth's surface regardless of the environmental condition. That means it will be penetrating any type of difficulty, whether it is cloud or any type of mist or anything is there, it will be penetrating everything, and it will be providing high resolution images even during the time of any kind of disturbance that is happening on the Earth, even cloud is there or rain is happening or whatever is happening. Okay, so it is a enhanced, it will be providing much more enhanced Earth observation during the time of clouds, rain, fire, because during the fire, if you try to get the images of the satellite, you will not be getting proper images because of the interruption, because of the smoke. But this satellite RISAT to BR1 will be able to penetrate any kind of obstruction and will provide you with a clear shot images from there. So how this enhanced Earth observation is going to helpful in the coming future? Like if we say, if we have much more enhanced Earth observation tools, like it will be much more, it will be much more precise, much more accurate, and get the information anytime, in any condition, in any condition. Okay, if we go by agriculture and irrigation management, we can monitor agriculture activities, access the health crop, optimize agriculture at any time and any conditions. Forestry and logging, so this will be continuously monitoring at that area how many trees are getting cut, what is the logging operation that is going on. It will be monitoring the deforestation with exact pinpoint, even during the type of when there is any kind of cloud or any kind of cover that is happening. Then coastal protection and surveillance, because it will be continuously monitoring at particular area, all the whole India, okay, whole Indian subcontinent. So it will be modifying, it will be, sorry, analyzing the whole coastline of our country, and it will even check if there is any kind of erosional activities that are happening, flooding activities, or because since it is monitoring at a particular location, it is measuring the minutest detail of everything. Okay, soil surveillance and disaster management, like in the soil surveillance, it will be mapping the quality of the soil and what are the whether the soil is being properly utilized or not. Okay, and it will also provide real time imaging regardless of the weather condition, because this is being utilized, because this is a highly accurate satellite which will be utilized even whatever the weather conditions are. It will help us in disaster preparedness, it will be prepare us beforehand. Okay, and during that time it will also enhance and provide early warning systems to various places. Okay, border monitoring, like how it is providing at during the round the clock border surveillance every time. Okay, critical intelligence, because otherwise other satellites are there, they are coming at certain point of time and then only providing the data, but during this time this satellite keeps on monitoring at particular location every time. Okay, so there are a lot of benefits, it will provide a very important timely information, and this satellite help us in empowering, in providing a valuable information which is provided, which we get at a time only, during that time only, during the live work only, we are getting over there. Okay, so this will further help us in proper decision making, and this will help in making us much more disaster resilience. Okay, and we can utilize their application at various places in order to our developmental goals and national security. So this is the satellite. Along with the satellite reset to BR1, we have even sent 9 foreign satellites along with that. Okay, so it is a radar imaging satellite observation, 628 kgs. It has been sent 576 kilometers the orbital height above the Earth's surface, X-band radar, and life is 5 years. Right, so along with that, Indian satellite, we have sent 1 Japanese satellite, 1 Italy satellite, 1 Israel satellite, and 6 US satellites. Okay, so this was the 75th launch mission from the Sriharikota and 37th launch from the first launch pad and 22nd flight of the PSLV with QL variant. Okay, so this is all the milestone that has been achieved during the launch of this satellite. Okay, now we are coming into the CartoSat satellite. Carto, the word este, it is related to the cartography. Okay, it is related to the cartographic application. So this cartography satellite is being utilized. This will be a dedicated satellite which will be utilized for only cartographic application, like map making and graph making, right? So because maps are very important for any type of planning that we are doing. Okay, whether urban planning, whether rural planning, or infrastructure development. Okay, and there are a lot of things are there. Okay, so that was launched on November 27, 2019, and it is a very important program, because this is specially being sent in order for map making purposes. Okay, so the mission objective is that it will be providing high resolution maps and images. Okay, state of the art imaging instruments are being set up in that. They will be providing with high resolution images with proper detailed information about the type of land cover, land uses, urban sprawl, like how the urban area has spread throughout the part of the country. Okay, cartographic applications, like it will help in map generation, updating the existing map, and creating a specialized map based on the type of requirement. So this is very important here. Okay, this will be providing to the point exact mapping data with proper scales and everything, which will be further utilize these maps, and like specialized map will be utilized for urban planning, natural resource management, or disaster mitigation, right? Even this, whatever the image are being provided by this cartoset, this will be helpful in planning and monitoring our infrastructure activity, like roadways is there, railway, bridges are, dams are there, so they will be having images that will be taken from the space. Okay, and with that images and with that maps and everything, we will be exactly find out like where exactly road has to be built, railway has to be built, what is the inclination and length, and what is the height and what is the depth, and everything we will be able to exactly find out. And it will also helpful in properly finding out like what is the surrounding area, how the surrounding area is developing, whether we can do anything is there. Then again, disaster management, this will be providing again a very timely information, like during the disaster like flood, earthquake and forest fire. Okay, so there are a lot of satellite which are working on common scales. Okay, they will be helpful in emergency evacuation and everything. Okay, so there is a technical specification. This the orbit of this cartosat satellite will be a sun synchronous polar orbit, so it will be like in a trajectory of the sun, which is at an altitude of 509, that is the low earth orbit that we are going to have. So this satellite, since it is in sun synchronous polar orbit, so this satellite will pass over the same region of the earth approximately at a same local solar time. That means if the satellite is traveling over the Delhi at 12 p.m., so next day also at 12 p.m. it will be crossing Delhi. Okay, so it will be because this, since this is in sun synchronous orbit, obviously it will be very consistent lightning condition for the imaging, because lights is very important for proper imaging purpose. Okay, now what is the imaging capabilities of this satellite? Okay, so since we have already said to you that this satellite is being put with advanced imaging sensors with high resolution images that they are going to capture, will have a spatial resolution of up to 25 centimeter. That means this is up to a spatial resolution of 25 centimeter, up to that high resolution image that we will be getting. So this level of resolution will be helpful in even identifying a very small object that is there on the earth surface. That is a very high resolution image that we are going to get. Okay, so this cartosat has been designed for a minimum of 5 years functioning. Okay, so this will be providing continuous valuable data during that time, and we will be having a lot of data to manage, and we will be having a lot of data to analyze. So we will having data analytics we can do over the whole data, and we can try to find out the various type of and we can infer from all these data. So this will be sent through PSLV C-47 rocket. Okay, and this is known as a workhorse of the ISRO. Okay, PSLV is known as the workhorse of the ISRO because it has been the most of the successful missions has been done with the help of a PSLV, Polar Satellite Launch Vehicle, and PSLV is known for its versatility. Okay, it has been sent various type of, even Mars orbiter mission has been sent with the help of this PSLV rocket, right? So this is about the Cartosat 3, and 13 nano satellites have been launched by the ISRO on November 27, 2019. So this is the 49th flight of the PSLV. This is a PSLV XL variant, right? So this XL variant and every type of variant we have already discussed in our previous lecture. Okay, so this is a 4-stage liquid propulsion, and we have a height of 44.4 meter, right? And this is a third generation agile advanced earth observation satellite. Application we have already discussed. Weight is 1625 kg. It has to be sent at an altitude of 509. That means it is a low earth orbit that is going to be sent, and mission life is 5 years. Along with that, 13 US commercial nano satellites are also being sent along with this Cartosat satellite. Okay, so US is always sending one or the various type of satellites along with our own launch vehicles. Okay, now we are moving towards the next instrument, that is called Gemini. Gemini is Gagan powered mariner instrument for navigation and information. So this Gagan powered marine instrument for navigation it is a very dedicated navigation and information system. So it is a satellite based advisory service which has been given by the government to assist the fishermen who are going for deep sea fishing. You know, whenever they go deep sea fishing, they lose the contact from the ground. Okay, they do not have proper signals of the mobile phone. They don't know if there any kind of problems that is coming in the sea, any kind of cyclone or any kind of wave, if that is happening, that is like if any high waves are coming or anything like that that is coming over there. Okay, so government has especially make a tool that is called Gemini tool, which will be satellite based advisory service to assist the deep sea fishermen. So the main thing is that the vital tool is that it will be disseminating the very important and crucial information regarding any type of disaster that is coming, or like tsunami is coming or high waves are coming, or it will also helping in finding out to tell farmers to fishermen is that where are the potential fishing zone. Like they will be able to properly map, okay, here at this places we have a lot of fishes are there. So based on that, it will provide you with advisory service, where to go, where not to go, which is a safe place, which is not a safe place. Okay, and it will even provide you with very important ocean states forecast. Okay, so this was developed by our Indian National Center for Oceanic Information Services with the help of Airport Authority of India. So the satellite data will be disseminated into their devices, whether it is phone or whether it is tablet. Okay, so this will help in enhanced safety and much more efficient way of deep sea fishing that is going to work, because during that time whenever they are there, so they will be getting a real time information to the fishermen. Okay, so the satellite technologies will be utilized, and with this satellite technology will be providing them with the real time data, critical data at a critical time, so that any fisherman who is having access to this data can make informed decision. Like if we are able to know that tsunami is coming, so we will be able to provide this information with the help of a satellite to the phone or a tablet to a fisherman, because where we cannot have a contact with a normal signal, so we can provide them with satellite based data. Okay, so fishermen can come to the coast and they can just leave the places from there. Okay, so this is how it will be providing much more better informations to the fishermen in all the way possible. Okay, so the components of the satellite, what is there, like it is a satellite based system. Okay, it is not like anything related to ground. It is a satellite based system, Gemini, that is being relied on the Gagan satellites, that is GPS aided geo augmented navigation, that is a Gagan satellite. Okay, so this will be exactly providing you with accurate positioning, navigation system and maritime operation, everything. Okay, then it will be connected with a Bluetooth mobile connection. Okay, so this device is equipped, any device which is equipped with Bluetooth, this will be providing and transferring the information, alerts, updates, advisory to their phones or smartphones or tablets or anything devices which is compatible through this data. Okay, obviously functionality is very important, because we know that when the fishermen go deep into the fishing, 50, 60, 70, 80, 90, 100 kilometers they sometimes go. Okay, so we wanted to provide them with early warning system regarding any type of disaster, like if any cyclone is getting generated, any tsunami that is getting generated, or any type of weather adverse weather condition that are being generated. So we can provide the fishermen with timely alerts so that they can take proactive measures. Then after that we have a potential fishing zone that we have already discussed. Like this satellite will be satellite data will be infusing the data into the mobile of fishermen in order to find out like where are the potential fishing zone. Like there are various places where the fishes have already gone wiped out, or some places. Okay, so in order to optimize their routes, whether they follow the correct route, where they should get good efficiency of the catch, in order to enhance the stability and also contribute to the sustainability of their catch, this potential fishing zone concept is also being included in this whole process. Then ocean state forecast Okay, Gemini will forecast ocean condition, like regarding what is the sea surface temperature is there, what is the current is there, whether the current is very high or low. Okay, water current, then wave height, whether the wave height are very high or low. Based on that, you can plan it. Okay, and then we can develop and we can collaborate with the neighboring nations, like we have a lot of neighboring nations like Saudi Arabia, Qatar, Oman is there, Yemen is there, Indonesia is there, Sri Lanka is there, Maldives is there, and our own country. A lot of people are being also included. They are also being part, and they are becoming part of the fishing activity. So we can provide them all these collaborative effort races to those people, and with the help of here the people are also some of the oceanographers and are also being included in these areas, so that they will be able to properly guide the farmers in all these areas. So that is why we have a premier institutions like INCOIS. Okay, and we have Airport Authority of India. These are the premier institute regarding the ocean information and advisory services in our country. So that is why this whole concept has been developed, and this Gemini based system has been linked with the satellite based system in order to help the fishermen in whatever the way possible. Okay, so this is how the Gemini Gagan powered marine instrument for navigation information work. Okay, so Gemini is a soapbox sized devices that is fitted in a fishing boat. Okay, so this is having a receiver. Okay, this Gemini is having a receiver which is fitted in a fishing boat. Okay, so there are server of INCOIS. They will receive the data from various ocean parameters, like what is the surface temperature, wind speed. Okay, then they will generate the forecast on daily weather, disaster warning, and everything, potential fishing zone. And this forecast is being transmitted to the Gemini devices through Gagan, GPS aided geo augmented navigation satellite. Okay, so they, like, if we have this fish, I'm not good at drawing, please bear with me. Okay, so if this is a farmer, okay, so here we have a Gemini, like a soap box, a small box is there which is fitted in a fishing boat. Okay, so and there is a servers, there are servers, and then we have a Gagan satellite. Okay, so this Gagan satellite will send the the forecast is transmitted to the 1 minute. Yeah, I think my pen is not working. No, I'm sorry for a few seconds of delay. Sorry. Okay, so here what will happen is that there will be a boat, and there will be a INCOIS servers are there. Okay, and here we will be having a Gagan satellite. Okay, Gagan satellite is being fed with the data of GSAT 8, GSAT 10, GSAT 15. Okay, so this boat is having a receiver. Okay, so INCOSPAR will be able to get the forecast. This forecast, how they are going to get this forecast, because they have a lot of receivers that are there in oceans. So from oceans receiver they will get a forecast, and this forecast they will transfer to the Gagan satellite. This Gagan satellite will send to the receiver into a boat that is called Gemini. Okay, so this is how the whole concept is going to work. Okay, so Gagan is used by Airport Authority of India for aircraft landing and takeoff also. Okay, so that is why INCOSPAR has tied up with Airport Authority of India to the technology, its Gemini device. Okay, so Gemini will send the information to the mobile application. Okay, with the help of a Bluetooth that is being present in a regional language. Okay, and even also tell about the potential fishing zone. Okay, you got it right. So from INCOSPAR server they will get a forecast. Forecast will be transferred to the Gagan satellite. Gagan satellite will send to the boat receiver, that is Gemini, and this Gemini will send it to the Bluetooth or a mobile phone or a pad which has been linked with the farmer's application. Okay, now we are moving towards the very flagship program, that is Chandrayaan. Okay, so this is very important that we wanted to discuss 3 Chandrayaan missions that we have sent. Okay, so we will be discussing each and every one. So you know, India wanted to first of all wanted to go about its natural satellite, that is moon. Okay, so India has sent its first lunar probe in October 2008. Okay, so every time whenever we send something, we have certain objective achieved to it. Okay, so India has moved, and India has also done successful Chandrayaan 2 mission. Only a part of it get failed, and Chandrayaan 3 was a whole successful, which we are still celebrating till now. Okay, so Chandrayaan 1 has made a lot of progress regarding exploration, and that is an Indian maiden voyage to the moon. Okay, and which is showing to the world India's capability in the space technologies. Like if we go by the objective of the Chandrayaan 1, first of all, the main purpose of Chandrayaan 1 was remote sensing of the moon. Then chemical and mineral composition finding of the moon. What is the lunar topography, like if there are any kind of hills or any kind of deep crevets are there, or what about the water ice? So this is what a main important thing that India wanted to look. Okay, whether there is any kind of water ice that is present on the surface of the moon or not. So along with the mission, with the Chandrayaan mission, we have sent two main components. Okay, there was a orbiter was there. One was the orbiter and one was the impactor. Orbiter means it will go to the moon and it will revolve around the moon. Okay, it will revolve around the moon, and there will be one impactor. That means that we will send and we will try to hit the moon surface. Okay, it will not like a landing, it will like we will be hitting that surface. Okay, so the impactor was module designed to crash land on the moon. Okay, because we wanted to put so hard impact on the moon so that the soil gets kicked up and we will be able to analyze the debris if there is any traces of water ice or any other substance. So the main objective of that impactor was to hit the surface of the moon so hard that some lunar soil gets kicked up, and that impactor will be able to analyze the debris regarding the traces of the water. Okay, so some of the important discoveries that has been done by our Chandrayaan 1 mission was, it has confirmed the water ice on the surface of the moon. That is the most notable achievement. Discovery of water molecules. Okay, because earlier it has been thought that the moon is a totally a dry area, but yeah, now since it has been discovered that in the moon they have a water ice is present over there, which shows that we will be having further lunar exploration and we will have much more potential human habitation in the future. That will be great. Okay, and Chandrayaan 1 has also created a detailed map of the lunar surface regarding its topography, mineralogy and geology. Okay, so this has further enhanced our own understanding, and now we have indigenous data for all these things. Okay, and even it has identified some of the lunar features like craters, volcanic structures and various type of minerals that are being present over there, because along with that we have sent certain instruments along with that. Okay, and then legacy and impact. Obviously this has put India onto the forefront in the space missions. Okay, and it has demonstrated that India has a capability and India has a expertise in further space research in the moon landing missions, and even the which shows that India has a good capability of providing a proper orbiter around anything, and India has got a deep space research and technological development in all these areas. So you can see here, this is a Chandrayaan 1 mission that we have sent. So in the geotransfer orbit, we have put a satellite and slowly we have raised their orbit, and then we have fired towards the moon. Okay, lunar transfer trajectory that we call it as, and after that there was a lunar insertion maneuver that has happened so that it enters into the orbit of the moon. Okay, so final orbiter is 100 kilometer polar. Okay, and initial orbit was 1000, and slowly we have descended it to 100 kilometer polar. Okay, so this is how it happens, the Chandrayaan mission, and there was an impactor that has been sent which has to impact this moon surface in order to kick some kind of some soil from there to understand whether there is water ice present or not. Then followed by Chandrayaan 1, we have a Chandrayaan 2 mission that has been sent after a gap of 10 years. Along with that, we have sent indigenous orbiter which will be orbiting the moon, and we have sent a lander which will be landing on the moon, and along the lander we have sent rover which will be going out of lander, and it will do roving over the surface of the moon. Okay, right? So only a part of this got failed, so we are able to properly insert the orbiter into the surface, but when we are trying to land the lander, it got crash landed just before it has reached to the surface around it. I think 2.1 kilometer was there. After that, we just got disconnected and that got crash landed. Okay, so the part or the lander part of that got failed, but actually half of the mission is already successful. Okay, so since we have in the first part only we have discovered that there is a lunar water, so here Chandrayaan to aim to map the location of the abundance of the water. That is the main task that has been given, to find out, to explore the history of the moon and also further potential resources that we can utilize in the future. Okay, and again lunar geology, further investigation into the lunar geology type of rocks and what is the unique chemical composition of that. Okay, so because if we wanted further exploration of the moon, so we need certain kind of proper understanding before we can further go for any kind of mission over there. Okay, so Chandrayaan 2 was having an orbiter. So under the orbiter part, this orbiter will be functioning to observe the lunar surface from a distance. They will collect the data. Communication, it will help in communication between the earth and the lander. How this is going to work, what, so this if this was a lunar surface and we have this orbiter, okay, and here we have a lander and here we have earth. Okay, so this lander will send the signal to the orbiter and orbiter will send the signal to the earth. So this is how the communication has to be established. Okay, so still now it is orbiting the moon surface, okay, and also providing valuable scientific data even after the lander setback, because the lander part got failed. But right now also this Chandrayaan 3 has utilized the orbiter part of the Chandrayaan 2, okay, for the proper data and handling. So along with the Chandrayaan 2 we have sent lander, that is the name is Vikram, okay, and the rover, that is Pragyan. Okay, so this lander will be having the rover inside it. Okay, so this lander was having various instruments like Vikram has a first soft landing that has to be do on the lunar surface, but because it has moved out of this intended path and got crash landed over there. Okay, then along with that we have also sent a rover that is called Pragyan. Okay, this is a AI powered rover was there to travel on the lunar surface this rover will has to do the chemical analysis of that places, but this part got totally failed. Okay, so launch has been done by the GSLV Mk3 M1 rocket. Okay, because this is because we have to carry a heavy lander and rover and orbiter along with that, so we require a heavy lift of satellite, right? And the main task is that India is attempting a southern polar region landing, because this is the places which is always away from the sun and the coldest part, and no other country have ever tried to do a landing at a southern polar region. Okay, so India wanted to do a soft landing at that area, but in the starting it got failed. Okay, and with this whole process India wanted to show the world that India has a technological know-how about the soft landing, but during the first phase in the Chandrayaan 2 it got failed, but because of this Chandrayaan 2 India has got a global recognition because all the things have already been reached, but at the last phase only we are not able to do the properly soft landing. Okay, and right now India has achieved in the Chandrayaan 3 we have achieved the soft landing at the global at the southern polar region of the moon. Okay, so this is Chandrayaan 2 where we have a orbiter that we wanted to send. We have a lander Vikram. This is the lander that has to go, and inside the lander Vikram we have a rover that is called Pragyan that we have sent, right? So objective was that to study the moon surface topography, mineralogy and everything. So these are the three important things. Orbiter, in the orbiter we were having lander. The lander is attached to the orbiter, okay, and inside the lander we are having a rover. Okay, so this whole process, this orbiter is of weight 2379 kg and lander is having a weight of 1471 kg and rover is having a weight of 27 kg. Okay, so here we have sent again we have followed a faint trajectory. Slowly we are increasing the orbit, and after that we have inserted into the orbit of a moon. Okay, so we have sent it through GSLV Mk3 rocket on September 7, 2019. Okay, so this is all about our Chandrayaan 2 mission. Now Yeah, we have already discussed that. I have put this slides in order to make sure that if you wanted to understand something else regarding that, so I just wanted to tell you over here, it is having around 14 payloads that has been sent scientific instrument along with rover. Rover is having certain instruments are there. Then we have a lander, we have having certain instruments are there. We have a orbiter, we are having certain instruments are there. So total 14 instruments are there. So number of 5 days spacecraft will be sent in transiting toward the moon, and 16 number of days spacecraft will hover around the earth, and 27 days spacecraft will spend around moon before lander separates. Okay, so this is how it has to go, and half of the work has been done by that. And after the failure of the lander and rover, so we have again planned a mission that is called Chandrayaan 3. Okay, Chandrayaan 3 is again being sent because here again we wanted to try, and we wanted the main purpose of this time is that we wanted to do a soft landing on the moon. Okay, so again we have sent the lander and we have sent a lander and a rover along with that. Okay, so there is a propulsion module which is taking this whole lander module along with them. Okay, and we have again made a rover which is having all the scientific instrument for study of the lunar surfaces. Here the mission objective are main is safe and soft landing on the lunar surface, to demonstrate rover mobility and conduct in situ. So main thing is that we wanted to do a safe and soft landing on the moon's southern polar region and rover mobility. Okay, we just land the lander and then we move out the rover from there. Okay, after that we do any kind of scientific instrument over. Okay, so lander is having payloads that is called CHESTE, that is called thermophysical experiment where measure thermal conductivity, like what is the temperature of the surface of the moon and inside of that. Then we have an instrument that is called ILSA. Okay, that is the instrument for lunar seismic activity, to find out which is going to be the activity where we have less seismic activity. Like we have India in our earth, we are having seismic activities, we get earthquakes and various other things. Okay, then we have a Langmuir probe, okay, that will find out the plasma density and variation. Then we have a passive laser retrofractory array. Okay, so a lunar laser imaging studies. Then rover payloads are having alpha particle spectrometer are there, and we have a laser induced breakdown spectroscope is there to find out the elemental composition wherever this rover is going to travel. Okay, so this is what the lander payload and rover payload are there. And what is the propulsion payload? They are having spectropolarimetry of habitable planet Earth, that is study spectral and polarimetric measurement of Earth from the lunar orbit. Okay, so this was a payload, that propulsion module is happening. Okay, then what are the advanced technologies that are there in the lander? Okay, we have our own altimeter, velocimeter, we have a inertial measurements are there. Okay, propulsion systems are there different, and then hazard detection avoidance system is there, because this is very very important, because last time we are not able to that, because if we want to do the safe landing, we should have a on-board hazard detection and avoidance system. That means the lander has been equipped with the hazard detection and avoidance system, so that if it finds any kind of issues onto the surface, it may change the landing site. Okay, then we have a landing leg mechanism is there. Okay, cold test has been already performed, hot test performed, and lander leg mechanism performance test. So these all are the technologies that are being utilized before, because we have already got a study from our Chandrayaan 2 failure. Then we are able to properly inculcate various new technologies in this, so that we should do the landing this time in a proper way. So this is a Chandrayaan 3, we are able to do it. Okay, so Chandrayaan 3 is a day to 42 days mission was there. Normally the countries usually send in 1 or 2 days, but we take 42 days because we wanted to do in various stages. Okay, so there was a rocket that we have kept for the Chandrayaan 3 having a cryogenic stages also being part of it. Okay, so here we have sent in this process, and propulsion module has to work for 3 to 6 months, and lander rover will work for 1 lunar day, that is close to 14 days. Okay, and this is how the whole process. This is the propulsion module along with the lander that has been there. So this is a lander and this is the propulsion module. This propulsion module will get separated, and this lander will be landing on the moon surface, and in this lander we are having a rover, which rover will be coming out and we will doing all the scientific experiment on the surface of the moon. Okay, so this is how the whole mission details are there regarding the Chandrayaan 3 mission. I hope everybody has got it regarding what was there regarding our Chandrayaan 3 mission, and this has become a successful mission. And the place where we have landed our lander, that we have named as Shiv Shakti, Shiv Shakti point. Okay, our Prime Minister has given that point as Shiv Shakti point, where India's lander module has landed onto the surface of the lunar surface or a moon surface. Okay. Okay, 1 minute. So here you can find out all the payloads here, what the rover is having, what payload, what is the propulsion module, and what lander are. So lander is having the maximum number of payloads with various instruments, and after that we have a payload in the rovers which has to do certain experiment, and then we have a propulsion module which is having one payload, that is Shiv. Now we are moving towards the Indian space policy of 2023. So right now, government has made Indian space policy a much more progressive policy. Okay. Yeah. So Indian space policy of 2023. Now Indian government earlier is only focusing on the government effort, but right now, since the government is looking for the startups in these areas, okay, government has opened this space sector towards the institutionalizing the private sector participation in all the way possible. Okay, so this whole process, the space policy, has been approved by the cabinet committee on the security to include the private players, so that we can have a much more better space reforms, provide conducive environment to the private industry, so that they can also get involved in these space programs, whether it is related to the rocket making, whether it is related to the satellite making, whether it is related to the propulsion modules, and whatever it is. Okay, so in the first phase only, the Indian space program has focused on finding out and putting the roles of various organization. Okay, so Indian Space Research Organization, New Space India Limited, and the Indian Space Promotion and Authority Center have got their own specific roles. Okay, so NSIL has got a role of strategic activities in demand driven mode. Okay, they will be looking for all the strategic activities that are going on, at the same time demand driven mode, and getting the orders. Okay, while in space will serve as the interface between ISRO and non-governmental entities or collaboration with them. Okay, and the role of ISRO is just to do research and development in the field of area. Okay, with operationalized mission transfer to the NSSI. Okay, so all the three bodies have got their separate roles, and the main important thing is the entry of the private player, where we wanted to encourage end-to-end space activity like satellite, rocket, data collection, launch vehicle, whatever it is. We will be all helping the private sector, and private entities will be also able to utilize the ISRO facility, like by providing certain nominal fees. You can even utilize the ISRO facilities, because government wanted to encourage the investment in this area, government wanted to encourage the startups in all these areas. So that is why government is keeping the field open for the private players. Okay, now what is the impact of this policy? Because we wanted to increase the Indian share in the global space. Right now is 2% to 10% in the coming year. Okay, so India wanted to become a significant. Still, we are on the fifth. We are the fifth national economy, because everywhere, whatever the world has done, whether it is related to the lunar probe, whether it is related to the Mars mission, whatever it is, India is on the fifth with every other country who are in the elite club. But the contribution of India is only 2% in the global space economy. That means India is not generating enough revenues for itself. Okay, so India wanted to develop as a launching capabilities, as a affordable launching capabilities country, like that. Okay, so right now a current status of India space sector is achievement. Yes, obviously we have a renowned global cost effective satellite manufacturing base. At the same time, we have a cost effective launching base. launching. Okay, we can launch with, that is why USA, Israel, Saudi Arabia's and various European countries are there who are sending their satellites to be launched from India. Okay, we have seen that where nano satellites are there, various satellites are there being launched by our India. Okay, and even Indian is focusing on the civilian and peaceful use of various outer space. So India has been fully aligned with all the international commitment that are there. Okay, so the government has even developed the Defense Space Agency and Defense Space Research Organization, highlighting India focus on the space defense capabilities. Okay, so India wanted to expand the satellite manufacturing. India wanted to do a research academia collaboration. Okay, so there is an initiative that is there, which is government is running like Samvad program. So this Samvad program, what we call it as, is a bit to foster space research among the young minds. Okay, so that is why ISRO has launched the Samvad mission. So here it is a student outreach program by ISRO Bangalore facility. Okay, so this will be facilitating, or it will be acting like a catalyst for nurturing the next generation space scientists. Okay, so India's space sector is contributing and evolving and also embracing the technologies, innovation, collaboration and strategic initiative. Just we wanted to reinforce the thing at a particular places. Okay, so this will help in providing with better space exploration and technologies. Okay, now we are having certain challenges are also that we are focusing on. So what are the challenges are there? Okay, first of all, there are lack of regulations. Okay, because of the lack of regulation on commercialization, like if we are providing and if we are opening the field for everybody, we may sometimes some big institution may monopolize the things. Okay, so this may challenge the space sector altogether. Then we have a space debris, that is yet a very big issue that is there. Okay, India is also making various type of projects are there that are being running in order to remove the space debris, in order to track the space debris, right? But still there is a huge accumulation of the space debris that are going on regarding spacecraft and satellites and all the thing. Then we have a lot of competition from the Chinas. Okay, like China's swift progress in the space industries has already exemplified, have their own navigation system. Beidou raises concerns. Okay, so the potential integration, we have a China Belt and Road Initiative that is coming. Okay, so they are now linking their Belt and Road Initiative with the space sector. Okay, so their growth is raising a huge issue, and this may lead to the weaponization of the space sector. Okay, now what exactly we can move forward and how we can promote the Indian space sector to move forward with better quality assets and without deterring their own economic growth. So first of all, we have to defend our space assets. Okay, so we have the projects like Project Netra, then we have a anti-satellite system is there that has been already been in place. So we will be also including checking the debris, right? Project Netra we have already discussed, right? Then we can have a international collaborations which will help further strengthening, like we can have a collaboration with Japan, European Union, Russia, NASA regarding the future of the space, how it is going to be there. Then here we wanted to also enhance the gender equality among people. Okay, so more and more women has to go towards that. We have to focus on providing more women with more career option in the space sector, because we wanted to make them their career so that they will be providing a gender equality institutions in our country. Okay, so because that is why only we will be able to have a diversity in that area. And obviously technological innovation we have already shown to the world. Right now still we are working on that. Okay, so we wanted to work on a technologies which help in cleaning the space, which can self eat the rocket. Okay, so this will self destruct the rocket during the time, or we can have a reclaiming rocket as we have a SpaceX is having. Okay, we can send the same rocket multiple times. Okay, we can have a robotics arms that we can utilize that. So if we are able to properly help the problems, help in the problems that we are facing, so we will be furthermore enhancing our technological capabilities, and this will not act like a hard power, but this will come as a soft power for India. This will come as a soft power to India. Okay, so this is all our Indian space policy. I hope all of you have enjoyed the session. Thank you so much for sitting for so long, and I hope you all have enjoyed it, and I hope you have made a notes of it, and all the things have been covered. We will be covering the current affairs in the coming session. So till then, bye bye, take care, and have a good day.